Hello and welcome back to Algebra 1 with Miss April. We are looking at Chapter 5 today. And in Chapter 5, we are examining operations with real numbers. And we're going to be looking at algebraic forms of addition and subtraction of real numbers to begin with here. So, whenever we're adding two non-zero numbers, and they have the same sign, we can add the absolute value and then add the sign back. So for example, if I have a negative 7 plus a negative 8, well, they have the same sign. So I can just add 7 and 8, which is 15, and then add the sign. So that sign, because I'm adding negative numbers, a negative added to a negative makes you more negative, right? We could demonstrate that on a number line. But let's just think that they have the same sign and we're adding them. So that sign holds true. These have the same sign, we're adding them. Two positives added together gets a positive, and two negatives added together gives you a negative. That makes sense, right? So if we add two non-zero numbers that have opposite signs, all right, so let's try that. Negative 7 plus a positive 8. All right. We can actually subtract the lesser value from the greater value and then just add the sign that makes sense. So for example, here, the greater value is 8 and we subtract 7. Well, that leaves us with 1. You can also think here, which digit is greater? Well, the 8 is greater. Then you ask, what sign does this 8 have? A positive sign. So that means my answer must be positive. If I had a situation where the negative was greater, my answer would be negative. Looking at the digits, 8 is a larger digit than 7. I know my sign is going to be negative. Do 8 minus 7, and that's negative. Again, when you have opposite signs and you're adding, you can ask yourself, which one is the bigger digit? Whatever sign that has, that's the sign of your answer. Now, we went over in past videos, in past chapters, the identity property. And the identity property of addition, basically, if I start with one number, any number I add 0 to, I end up with that same number, the identical number. Another thing to think about is when you're subtracting two numbers, you add the opposite of the second number to the first number, using the other rules that we just kind of went over. But let's look at that. So I have, let's say I have a negative 7, and I want to subtract a negative 5. There are a few things we can think about here. Now, the rule says add the opposite of the second number. But here, I would like you to think about a double negative. Whenever you're subtracting a negative number, it's like saying I'm not hungry, right? That means you are hungry. So when we have a negative and a negative together, I want you to draw a couple lines there and change that sign. Because a not is a positive. So we have negative 7 plus 5. And that's a little easier to think about. Now we can go back to the other rules, and we see that the 7 is greater and it's negative, so our answer will be negative. And the difference between the 7 and the 5 is 2. Another example, let's say you have a positive number and you are, well, let's do a negative. There. So this is the same as saying negative 7 plus negative 5. Right there, the same thing. We can add the negative 5, which is essentially what's going on. But if that doesn't make sense to your brain, then you can think kind of in a number line where if you're already starting off at negative 7 and you're taking away more, you must be going more negative. So negative 7 minus 5 is basically a negative 7 plus a negative 5, leaving us more negative at negative 12. So now let's look at algebraic multiplication and division rules for signed numbers. When we multiply or divide two non-zero numbers, I'm sorry if you are hearing my cat purring and making noise in the background. When we multiply two non-zero numbers that have the same sign, for example, I have a negative 5 times a negative 2. They have the same sign. So they kind of cancel each other out, right? So when they have the same sign, then we're looking at the opposite of those signs, where we need a positive answer. We can just think 5 times 2, which is 10. And it's going to be positive because we have two negatives. Now, another way that I like to look at this is no matter how many numbers you're multiplying or dividing, and you have this equation, right? And if it's all multiplication, you can just count up the negatives. 1, 2, 3 negatives. So we have 3 negatives. That's an odd number of negatives. So when I have an odd number of negatives in my entire equation, my answer will be negative, okay? A negative answer. If I have an even number of negatives, my answer will be positive, okay? So if I said something like this, my answer is always going to be positive, right? An odd number of negatives yields a negative answer. An even number of negatives yields a positive answer. And it can be just that simple, whether you're dividing or multiplying. Okay, you can just do the multiplication, or you can just do the division and then count how many negatives there are. So if I have just one negative, just one negative, then I have a negative answer. Let's also talk about what happens when you divide any number or by 0. So 5 divided by 0. Well, it's 0. How many times does 0 go into 5? 0 times. But more than that, we say that it's undefined because it doesn't make sense. 5 divided by 0. Well, 0 goes into... Can you put nothing into something? Well, yeah, it's just undefined. Let's leave it there. Now, when we're multiplying by 0, you know the answer is always 0. We've went over that before. Okay, that's the 0 property of multiplication. So sometimes we're looking at fractional answers, right? And in algebra, you should know that you really will not be seeing this kind of division symbol. All right, if we are indicating division, it's with the fraction bar. Okay, so if I give you something like that, I'll put a negative in front of it, and it's beside something like this. Anytime you have parenthesis beside a parenthesis, and there's no other operation in between them, then that implies multiplication. So many ways to show multiplication, right? You can use the times symbol. You can use these parentheses. And if I put a variable beside it, 2 is the coefficient, y is the variable, and there's no other operation between them, that means 2 times y. I could say it like this, right? Use that little dot. All multiplication, even if I have 1, 2, 1, 2, that is outside the parentheses and 1 that's trapped inside, that's multiplication, 2 times 2. All right, so here we have 1 negative, so our answer will be negative. We multiply straight across with fractions. 8 times 3, and then 4 times 5. And this will reduce, and always reduce your answers to the simplest form, unless the instructions are explicit that you should not for some other reason. Okay, well, I can see that these are both even numbers. I can think about what numbers will divide into the numerator and the denominator, both. And I know that 4 will divide into each one of these. Right, 6 times 4 is 24, leaves me with a 6. And 4 goes into 20 5 times. And there's my answer, a positive 6/5. And we don't have to change it to a mixed number. It is an improper form. And in most algebra, you will be using improper forms. All right, this concludes chapter 5. I will see you for chapter 6.